Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rashidi bin Rizali and my student ID is 2020811766.
Assalamualaikum. My name is Muhammad Muhammad bin Khairul Nizam. My student ID is 2020893022.
Assalamualaikum. My name is Muhammad Arif Naim Zakaria. My student ID is 2020892178.
So right now we are going to present about subtopic of the topic application of differentiation. So this is the content of this video. First, we have introduction of the topic. Second, problem solving, and last one, we have conclusion. So the introduction of applied maximum and minimum problem. In calculus, there are many problems involve function which you want to find maximum and minimum value. The restriction stated or implied for such function will determine the domain from which you must work. So the function together with its domain will suggest which technique is appropriate to use in determining a maximum or minimum value. So before we start, we must know what is differentiation. Differentiation is a process in mathematics to find the derivative or the rate of change of a function. There are a few techniques of differentiation such as derivative of sum and difference, the product rule, and last one is the quotient rule. So when do we apply differentiation? So we need to refer to the question first. Basically, we use differentiation when the question asks us to find the rate of change or the derivative of a function. So what the other application of differentiation? First, increase, decrease and concavity. Second, relative extrema, first and second derivative test. Third, applied maximum and minimum. And last one, rule theorem and mean value theorem.
Problem: in a certain chemical manufacturing process, the daily weight Y of defective chemical output depends on the total weight X of all output according to the empirical formula, where X and Y are in kilograms. If the profit is 50 ringgit per kilogram, non-defective chemical produced, and the loss is 40 ringgit per kilogram of defective chemical produced. How many kilograms of chemical should be produced daily to maximize the total daily profit? The objective of this question is to find how many kilograms of chemical should be produced daily to maximize the total daily profit. Based on this question, we can find that the profit from non-defective chemical is equal to 50 X minus Y, and the loss from defective chemical we can make it such as 40Y. Px 50 X minus Y minus 40Y, 50X minus 90Y. So we can find that Y is equal to 0.01x plus 0.05x squared. Px 50x minus 90 multiplied with 0.01x plus 0.05x squared. You can find that 50x minus 0.9x minus 4.5 squared. The answer is 49.1x minus 4.5x squared.
So for the next step is 49.1x minus 4.5x square. We need to differentiate it, and then we're gonna get p prime x equal to 49.1 minus 9x, and then we replace the square, the prime, the p prime with 0, which is 0 equal to 49.1 minus 9x, and then x must be equal to negative 49.1 over negative 9. And finally, the answer is x equal to 5.56. So here we need to make sure we need to differentiate the p value. So to maximize the total daily profit, 5.56 kilogram of chemical should be produced daily. So for the conclusion, in conclusion, maximum and minimum are important topic in calculus. It is the approach for finding maximum or minimum value of any function. It is practically very helpful as it helps in solving the complex problems. Based on the discussion just now, we can conclude that this is the best method to solve maximum and minimum problem. So before ending this presentation, I just wanted to say this is the reference. Thank you. So we have a few references that we include in this presentation. So first, we use our Calculus 1 Science and Civil Engineering books. The second one is we visit the Google site, MAT183, which is our lecturer site. And then we also refer to the YouTube, which provide in this, the link is provided here. So before ending this meeting, I just want to say thank you to Arif Naim and Rashidi that we are just want to say this is an amazing experience working together in a group to complete the task. And then so finally at the end we finally made a video of the presentation that we learned, and I just want to say that all of us really contribute in this assignment, and thank you and Assalamualaikum.
Dah, stop. Dah.